Hi everyone, and welcome to the continuation of the solutions for Cape Pure Mathematics, May-June 2019. So in this video we will be dealing with question number 2. So let's get right into it. So question number 2 says, at least part A, it goes, let A for x a member of the real numbers and x greater than or equal to 1, a function f that maps a to the set of real numbers is defined by this expression. Show that f is 1 to 1. Okay, so before I proceed to show that what f is 1 to 1, I would like to first state what 1 to 1 is. Now this is not necessary for this question. You could approach it without the definition, but for your understanding, I think it's best that I provide a definition for 1 to 1. So the function f is 1 to 1 if and only if. So the two f's is for if and only if for all x1 and x2 a member, for all x1 and x2 that are members of A, f of x1, sorry, let me just change this tip. F of x1 is equal to f of x2, then x1 is equal to x2. So for us to show that this function f of x is equal to x squared minus x is 1 to 1, or the next word for 1 to 1 is injective. To show that it is 1 to 1 or injective, we must show for a x1 and x2 that exists in this domain, which x greater than or equal to 1, that if f of x1 is equal to f of x2, then we must show that we are able to get that x1 is equal to x2. So this is the definition for a function that is injective or 1 to 1. And we will now proceed with a proof to show that this expression is 1 to 1 using the definition. Right, so in order to do that, I would say we will start off saying that f of, x1 is equal to f of x2. So we'll start with this expression and we will have to end up showing that x1 is equal to x2. And if that is the case, then the function x squared minus x is 1 to 1 or injective. So f of x1 would be x1 squared minus x1 is equal to x2 squared minus x2. So I just substitute this expression for x1 in x squared minus x, and the x2 into x squared minus x2 squared minus x2. So let's carry across this x2 squared on this side and bring this x1 on this side. Let's see what we get. So x1 squared is equal this x1 on this side, x1 minus x2. So this is the difference of two squares. So I could rewrite this as x1 minus x2, x1 plus x2 is equal to x1 minus x2. Now the first thing I would say is that you would be tempted to cancel x1 minus x2 with this x1 minus x2 on that side. So you're very much tempted to take this and cancel it with that side. You should not do that. You will not be able to get your solution if you do that, because you will be losing one of your potential solutions. So do not cancel from this x1 minus x2 with this one. Just bring the expression on this side and make it equal to 0, so you'll be able to keep this x1 minus x2 solution. So I'm going to write x1 minus x2, x1 plus x2. This comes over on the side, minus x1 minus x2 is equal to 0. So x1 minus x2 is common, so we could take that out. Draw a big bracket. This will turn to minus 1 is equal to 0. So it is better to write the expression like this, x2 minus x1 into this big bracket x1 plus x2 minus 1, than to cancel it from this location here. So you're able to keep both solutions. So if this multiplied by this is equal to 0, what that leads you to say that either x1 minus x2 is 0, therefore x1 is equal to x2, or x1 plus x2 minus 1 is 0. So therefore x1 plus x2 is equal to 1. Now we were given a condition. The condition we were given on the limitations for our domain is that x must be greater than or equal to 1. So we are not accepting all values of x. X must be greater than or equal to 1. Now we have this expression x1 plus x2 is 2. So we have to figure out if this violates this condition that x must be less than or equal to 1. So let's start off by saying, so we have x1 plus x2 is 1, so therefore x1, sorry, let me just erase that. So therefore x1 is obviously 1 minus x2. But we know that x1 must be greater than or equal to 1. And x2 must be greater than or equal to 1 because they both belong to the domain A. So if x1 is greater than or equal to 1, then that means that 1 minus x2 must be greater than or equal to 1. So this gives x2 must be greater than, so if you you can't really carry it across on that side, so let me rewrite this. So x2 will come over on this side, and then we have 0. Now this condition here, or this result, violates our declaration that x2 has to be greater than or equal to 1. So you would say this contradicts the statement that x2. Hence, x1 plus x2 minus 1 is equal to 0 is false. So this, if this is false, that leaves us with this solution alone, where x1 minus x2 is 0, so which implies that x1 is equal to x2. So therefore, we have successfully proven that f of x is injective or one-to-one. Okay. All right, so let's move on. We are now on number 2, part B. So number 2, part B, we are given an expression for f, and we are also given an expression for g of x, and we have to find f inverse. Alright, so to find f inverse, well, how do you find f inverse geometrically? So again, this is not required for the question, this is just me providing some explanation. So if you have a line y is equal to x, that's a poor line, but, and you have a function f of x, then f inverse is the reflection of this function over this line y is equal to x. So I'll do a poor drawing, but it'll look something like that. Okay, so that's the geometric interpretation of this is f inverse. This is f. So it's a reflection of your function over the line y is equal to x for you to get f inverse. Again, this is not required to solve the question. I'm just trying to give you a little bit of background on how you go about getting f inverse, at least what it looks like geometrically. So how do you perform this this request of getting the inverse given f of x is equal to 3x plus 1? Well, it's pretty straightforward. So you would say that let f of x equal to y. So you say y is equal to 3x plus 1. So to find f inverse, we interchange x and y. So therefore, that therefore is a trailing edge here. Therefore, x is equal to 3 f inverse. Well, let's not write it like that yet. 3 y plus 1, so x minus 1 over 3 is y, which is equal to f inverse of x. So I prefer to write it f inverse of x is x minus 1 over 3. Let's write it out. Looks better. Because you may be using this in the second part to come. So that was straightforward. You just substitute. You write your function as y is equal to 3x plus 1 and then interchange the x and the y and you get the f inverse. So now we are asked to find f inverse. It's a composition of two functions, f inverse with an operator on, or composition function on g. So this could be written as, let me just bring this across here. So this could be written as f inverse composition of a function g is simply f inverse with g of x as its argument, which is g of x was given to us earlier on, and it is g of x is e to the 3x. E to the 3x. So f inverse is given by this function, so we have to substitute e to the 3x wherever we have x. So that's straightforward. So this is e to the 3x minus 1 on 3 is what is given by f inverse g. Again, another straightforward question. Okay, so moving right along, we are now asked to solve this equation. 3 minus 4 over 9 to the x minus 4 81 to the x. So how would you approach this question? Well, we note that we have n to the x and we have 81 to the x. So we first of all concentrate on these two terms. This 81 is 9 squared. So we have a 9 to the x. So this 81 could be written as 9 squared and multiplied by an x. So it will be 9 to the 2x. So we can make some headway with the question if we rewrite this 81 as 9 2x, 9 to the power of 2x. And in that way we could probably form an equation that looks like a quadratic that we could probably solve. So that's the approach that I would like to take. Now you may say that we could work all the way down to 3. So this 9 to the x could probably turn to 3, and this 81 could be turned to a factor of 3 and you get a higher number. Yes, that would work, but it's probably less working for us to remain with 9 to the x, and here will simply be 9 to the 2x. So let's adopt that approach. So if I rewrite, well, we start off with the equation. So we have 3 minus 4 over 9 to the x minus 4 over 81x is 0. So this is 3 minus 4 9 to the x minus 4 9 to the squared, and of course this is raised to the x, so this is the same as 3 minus 4 9 to the x minus 4 9 to the 2x is equal to 0. Right, so we have a common term, 9 to the x, so we could hopefully move forward and try to solve that. But we need to remove it from the denominator here so we could work with it. One way of doing this is to multiply each term by 9 to the 2x. So we multiply each term by 9 to the 2x. So this is 3, 9 to the 2x minus 4, 9 to the x, because 9 to the x multiplied by 9 to the 2x, 9 to the x will cancel with 1, so you're left with 9 to the x, and then you have minus 4 is equal to 0. Let's remove these 9 to the x and probably use a variable that is a little more comfortable for us to work with. So let's say let y equal to 9 to the x. Alright, let me just rewrite this. My handwriting is already poor, so I will try to be as neat as possible. 9 to the x. So I don't know. Oh dear. Right. So we let y equal to 9 to the x, so we could rewrite this as, let's call this equation 1. Write equation 1, this will be 3. If y is 9 to the x, then 9 to the 2x is y squared. Minus 4y minus 4 is equal to 0. So now I have a very familiar quadratic to solve. So I look at my coefficients. So I see a 3 here and a 4, and I want factors of minus 12 that when I add them I get minus 4. Well, that's an easy one, because that is simply minus 6 by 2. Minus 6 by 2, when I add it, I get minus 4. So I would say 3y squared minus 6y plus 2y minus 4 is 0. So here, when we factorize out, let's take out 3y. So that leaves us with y minus 2. Over here, let's take out a 2. Y minus 2. So continuing the factorization, it be 3y plus 2. And then y minus 2 is equal to 0. So therefore, we are going to get 3y plus 2 is 0. So y would be minus 2 on 3. And then we're going to have y minus 2 is 0. Y is equal to 2. But we have to remember that y is 9 to the x. So we have to substitute back y for 9 to the x. So we have 9 to the x is minus 2 on 3. 9 to the x is equal to 2. So for 9 to the x is equal to minus 2 on 3, this is an impossible solution, so not a solution. For x, or solution does not exist. Why does this solution not exist? Well, to find for x, you're going to have to take logarithms, or we could use ln on both sides, and you would face a scenario where you have to find the log of a negative number or the ln of a negative number, and that does not exist. So We now look at this solution. So we have 9x to the 2. So you could say ln 9x is ln 2. So x ln 9 is ln 2. So therefore x is ln 2 over ln 9. That is my answer for x. I would be tempted to leave that answer here in this form, but if you want an exact answer for this, I believe it's 0.315 to 3 decimal places. Okay. All right, so let's move on to part D. Sorry. Part D is a cubic equation. This is power tree here. Probably having some problems seeing it with this writing, but that's the power tree. And this cubic equation has roots alpha, beta, and gamma. And we have to state the values of when you sum the roots, when you take the product of all three, and also this combination we have here. This problem relies on you knowing the relationship between the roots of a cubic equation and the coefficients of a cubic equation. So for a general cubic equation, of the form a x cubed plus bx squared plus, these are the coefficients of this cubic equation. If you were to rewrite these coefficients in terms of the roots alpha, beta, and gamma, these coefficients would look like this. Well, the x cubed term remains unchanged, ax cubed, but your b term is really ab, oh sorry, okay, it is a alpha plus beta plus gamma x squared plus e. You're going to take the product of two of them for each one of the terms. This is beta gamma. That represents your coefficient of x. And then the last one is the product of all three. Alpha, beta, gamma. And you need to stick in a in front, which I left out. So let me rewrite that. So the a would be in front here, in addition to the roots. Alpha, beta, gamma. So the key over here is to compare. So, well, you could immediately read off the a. That's the coefficient in front of the x cubed term. B, whatever b is, which is here, that maps to this value for b. Minus a alpha plus beta plus gamma. So you take any first coefficient a, of course you include any minus sign and the plus in all three roots. C, is equivalent to this. Again, you have a, you multiplying by a, and you also take any product of any two roots and in their combination and adding them together. And lastly, d is equivalent to all three roots as a product, including e, with a minus sign in front. So when they ask us, so this information of course is important for you to proceed with the question. So when we are asked state the values of alpha plus beta plus gamma, the polynomial, so I'll write it at the bottom here, is, let's go with a different color, 2x cubed minus 5x squared plus 4x plus 6, and that is equal to 0. Well, it's an equation, not a polynomial alone. So clearly, comparing coefficients, we will get that e is 2, so that's the easy one. And then we have minus e alpha plus beta plus gamma. Well, that is equal to minus 5. So we are asked to find alpha plus beta plus gamma, so they just want this tree as a sum. They don't want it individually. So then alpha plus beta plus gamma is equal to minus 5 divided by the value of e, well, which is minus 2. So the answer we have is 5 over 2 for this expression. Next, we are asked for alpha beta plus alpha gamma plus beta gamma, which is this expression here with just an e in front. So e alpha beta plus alpha gamma plus beta gamma is equal to 4. So alpha beta alpha gamma is equal to 4 over 2, which is 2. Lastly, minus e to the alpha beta is 6, and of course they want to know alpha beta, the product of all three roots. So minus e alpha beta gamma is equal to positive 6. So alpha beta gamma is 6 divided by minus 2 minus 3. Right? So let's move on. Hence or otherwise, determine the equation with roots alpha squared, beta squared, and gamma squared. So they are asking to use the equations we have here. E being 2, alpha, beta plus gamma being 5 on 2. This product being equal to 2, and the product of all three being equal to minus 3. So we are asked to use this information to find the equation, the cubic equation when alpha squared, the roots alpha squared, beta squared, and gamma squared are derived from that new cubic equation, and we got some help over here. So let's go back to the comparison. Let's look at B. So we can't find A yet. They did not give us information so that we could get the constant. So let's look at B. B being the coefficient of x squared. So the coefficient of x squared is equal to minus A plus all three roots. So in this case, if I would say the cubic polynomial will be written as A x cubed plus bx squared plus cx plus d. And we know that b is equal to minus a. And you sum all three of the roots. But if the three roots is given by alpha squared, beta squared, and gamma squared, then you just b is equal to alpha squared plus beta squared plus gamma squared. And they gave us the simplification of alpha squared plus beta squared plus gamma squared. It simplifies into this expression. So that is equal to minus a alpha plus beta plus gamma, all that to be squared, minus 2 alpha beta alpha gamma beta gamma. Now we are lucky, well, the question is designed like this, that we actually know the value for this and we know the value for that. Right, so this is equal to minus e alpha plus beta plus gamma. We got the answer for that higher up. Alpha plus beta plus gamma is 5 over 2. So this is 5 over 2 squared minus 2. What is the product of these roots? I think we got that to be 2. That's very handy. So let's just simplify this. So we have minus e 25 over 4 minus 4. So that is minus e. So 25 over 4 minus 4. 4 is 16 on 4. That should be 9 on 4. So I'll just write this properly. Minus 9e on 4 is what b is. So hopefully, as we move on, we could find a value for a, and we would be able to find out the exact b term. So that's for b. So c is given by this expression, and we have to multiply by a, and we know what this is. So in this case, where our roots are alpha squared, beta squared, and gamma squared, c is your constant a multiplied by uh, alpha squared by beta squared plus alpha squared by gamma squared plus beta squared by gamma squared. Alright, so that should be the combination for C. Alpha, beta, alpha, gamma, alpha, beta, gamma, sorry. Of course, you could rewrite this as E alpha, beta, all to be squared, plus alpha, gamma, all to be squared, plus beta, gamma. So thankfully, they gave us an expression for alpha beta squared, gamma beta squared, beta gamma squared, the expansion for it, which is given by this expression. So I could write C is equal to E. I have to rewrite this expression. Alpha beta, alpha gamma, beta gamma all to be squared, minus 2 alpha beta gamma, alpha plus beta plus gamma. Okay, so we have these values for C. Well, alpha, beta, alpha, gamma, and beta, gamma, well, that is 2. So 2 to be squared is 4. Minus 2. Alpha, beta, gamma, we got that on top. Alpha, beta, gamma, we have as minus 3. So that's a minus 2 already, so this is minus 3. And then alpha plus beta plus gamma, well, that is 5 on 2. So that is E. 4 plus 6 by 5 on 2. 6 5s are 30. So, well, the 2 will cancel here. So that's a 3. So that's 3 by 5 is 15 and 4 is 19. Okay. So C is 19E. That's the C. We know that D is equal to, let's check and see, or remind ourselves what D is. D is minus A alpha beta gamma. So D would be minus E. So in this case, we have the squares, alpha squared, beta squared, gamma squared, which is minus E. Alpha beta gamma all to be squared. And that value for alpha beta gamma we got as minus 3. So if that is minus 3, is minus 9e. So if I have to rewrite this new polynomial, so the polynomial is equal to ax cubed. B is given by this expression, minus 9e over 4 x squared. C is 19e. And D is minus 9e. So the question asked, hence or otherwise determine the equation with roots. So our value for A was 2. So we could write this as, right, so let's factorize out this A. So yeah, that is A x cubed minus 9 and 4 x squared plus 19x minus 9. So this is the polynomial that would have your roots as being alpha squared, beta squared, and gamma squared. Now, so what about this A? Well, the strange thing when this question was written, if you go all the way on top here, it was equal to 0. So if you have equal to 0, then we get to remove the A, factorize out the A, or the A being 0, sorry. And we could say that the function is x cubed minus 9 x to the 4th x squared plus 19x minus 9 is 0. So this is your final polynomial with roots alpha squared, beta squared, and gamma squared. So that completes question number 2 in KPO Maths 2019 June paper. So look out for question 3 in our next video. Thank you.